Hello everyone, how are you all? Hope you all are fine. Today in this video, I'll be discussing about the binomial distribution of probability. Binomial distribution is a distribution which is related to Bernoulli trials. Bernoulli trials means what type of trials? Bernoulli trials. Like if we perform any trial where the number of trials is finite, like if we toss a coin 10 times, we can say number of trials is finite. Or let's say a die is rolled 20 times, number of trials 20 times. So in such case what sort of problem we face? Like suppose a coin is tossed 10 times and we are asked to find the probability of getting head 4 times. In this case the sample space cannot be calculated simply because 10 times when a coin is tossed or at once 10 coins are tossed, then what can be the sample space? All the 10 coins will be showing head. This is one case. All the coins can be showing tail. This is another case. One coin showing tail and remaining all the 9 coins will be telling another. So we cannot determine simply the sample space. Here to solve such problem we take help of binomial distribution. But binomial distribution, before we solve the problem taking the help of binomial distribution, we need to understand, we need to know whether the experiment, whether the trial is related to Bernoulli trial or not. So Bernoulli trial means when a coin is tossed 10 times, we can say number of trials finite. So first important point, the number of trials must be finite. So if a trial is containing finite number of trials, then that is the first case of Bernoulli trial. Secondly, it must have only 2 outcomes. Like if a coin is tossed 10 times, we require head 4 times. Then in every trial either head will come or tail will come. Either head will come or head will not come. So it is showing 2 outcomes. Simply second example, if a card is taken out, from a pack of 52 cards, then either king will come or king will not come. In this way, either I like this or I don't like this. In this way we have to check the outcome is showing 2 possibilities or not. The required, which is required, that comes under the success, and which we don't need, which is not required, that comes under the failure. So if trial containing only 2 outcomes, success and failure, this is the second important case for Bernoulli trial. Third, events must be independent. Like in first trial, whatever comes, that must not be affecting the outcome of second trial. So when a coin is tossed 10 times, in first trial if coin is showing head, it doesn't mean in second trial because of that head another thing will occur. In this way, if events are independent, then it is related to Bernoulli trials. Next, probability remains same in each trial. In each trial the probability must be same. Must be same means if a coin is tossed 10 times, in first time probability of getting head is 1/t. Similarly, in second trial also probability of getting head is 1/2. In third trial also probability of getting head is 1/2. In this way, if a trial is going through these 4 conditions, then we need to be sure the trial is related to Bernoulli trials. So if trial is Bernoulli trial, then to solve the problem related to probability, we can use the concept of binomial distribution, because the discrete distribution related to Bernoulli trial is in fact binomial distribution. So in this case, if we need to calculate probability of getting our successful outcome, then we apply formula combination of n objects by taking r at a time, p to the power r into q to the power n minus r. The main and most important formula for the binomial distribution is this. Now what do the letters denote? Here This n stands for number of trials. N stands for number of trials. R, number of successful outcome, whatever we need that. Like if a coin is tossed 10 times and we need 4 times head, then 4 becomes number of success. Then P is probability of successful outcome in each trial. Q, probability of failure outcome in each trial. Then the main thing, P plus Q is always 1. How 1? Probability of being fail and probability of being pass, they are complement of each other. Probability of getting head in a trial is 1 by 2. Then probability of getting tail in trial will be 1 by 2. 1 by 2 plus 1 by 2 is equal to 1. So in each trial, P plus Q always shows 1. So on basis of this formula, we will be able to solve the problem. Have a look. Let's solve a problem. This problem was asked in 2073 board examination of set C, question number 8B. 4 dice are rolled simultaneously and we need to calculate probability of getting exactly 3 sixes and exactly 2 sixes. Now let's see whether the problem is related to binomial distribution or not. We need to go through certain points to determine whether the problem is related to binomial distribution or not. So for this, 4 dice are rolled and we are concerned with 6. This is our successful outcome. Successful outcome, we need 6. So either 6 will come or 6 will not come. Fine. Number of trials is finite. 4 dice are rolled. It is similar to a die is rolled 4 times. So number of trial is fixed. Only 2 outcomes are there. Either 6 will come or 6 will not come. Next, the case is related to independent events and probability of getting 6 in each trial is 1 by 6. So this problem is related to Bernoulli trials and we can apply the concept of binomial distribution. So here, when 4 die are rolled, then for this we can say number of trials, n is equal to 4 and we need 6 3 times. So our successful is getting 6. We need 6. So here we can write probability of success outcome is probability of getting a 6, that is 1 out of 6, and which is our P. So probability of failure outcome will be 1 minus P, that is 1 minus 1 by 6 equal to 5 by 6, and this is our Q. And we need 3 6. So case 1, probability of getting successful outcome 3 times are equal to 3. Successful outcome 3 times. So the formula C, n, number of trials 4, 3, P to the power R into q to the power n minus r. N is 4 minus r. So it gives n factorial, n minus r factorial, r factorial. P is 1 by 6 cube and 5 by 6 power 1, and here 4 into 3 factorial, 4 will be cancelled, 3 factorial will be cancelled, 4 into 1 by 6 into 6 into 6, 1 by 5 by 6, which gives us 4 into 5 by 6 into 6 into 6 into 6. The simplification will gives the value of this probability. Similarly, second here we need probability of getting exactly 2 6s. Probability 2 6s. Same way, combination of n factorial by taking 2 at a time, p to the power r into q to the power n minus r, where it is n factorial, n minus r factorial 1 by 6 square into 5 by 6 square. The simplification will gives the value of this. Have a look. Now next question, let's solve. The question is, find the probability of getting 2 heads, at least 2 heads in 5 tosses of a coin. This question was asked in 2072 in sheet C in question number 8B, that is 4 marks question. So first of all, how do we solve this problem? How do we apply the concept of again binomial distribution? First of all, we need to be sure whether the distribution is related to Bernoulli trials or not. Again, same way, you can see here, like the previous question, 5 tosses of a coin means a coin is tossed 5 times. A coin is tossed 5 times means number of trials finite. Again, whatever comes in one trial will not affect the outcome of second trial. So this is the case of independent events. Probability of getting successful outcome in every trial is constant. Like probability of getting head in one trial is 1 by 2. Probability of getting head in second trial is also 1 by 2. So this is the case related to Bernoulli trials, and we can apply the concept of binomial distribution. So here what do we see? First of all, we need to determine the number of trials. 5 tosses of a coin. So we can write here number of trials n is equal to 5. We need head for question number 1. Head. This is for question number 1. So probability of successful outcome is equal to probability of getting head, that is 1 by 2, and this is P. Probability of getting head single, 2 heads, this 2 head means head 2 times. We need to understand in this way. So these 2 heads represent 2 times successful outcome we need. So here probability of successful outcome is probability of getting head, that is 1 by 2. So probability of the failure outcome will be Q, and that is 1 minus P equal to 1 minus 1 by 2 is equal to 1 by 2. And for question number 1, success, number of success, how many times we need to be success? 2 times, 2 heads required. So probability of getting success 2 times is equal to CNR, n is 5, 5R, P to the power R into Q to the power n minus R. So here we get n factorial, n minus R factorial, P square, that is 1 by 2 square into 1 by 2 cube, and the simplification will gives us the answer of this. So second, at least 2 head. At least 2 head means minimum 2, more than 2 also it can contain. So here we write probability of being success at least 2 times, or 3 times, or 4 times. And now we cannot write 5 times because the case is related to, okay, look here, 5 tosses. So it will contain 5 as well as. are equal to 5. More than 5 we cannot do. More than 5 why can't we do? Because the case is related to 5 tosses. The coin has been tossed 5 times and we are going to calculate the probability of getting 2 heads, at least 2 heads. So at least 2 heads, it starts from 2 and reaches up to the last trial. So here we apply the formula again, C N R into P to the power R. P is 1 by 2, we can write the value 1 by 2 to the power R into 1 by 2 N minus R, plus again C N R P to the power R into Q to the power N minus R, plus again 4 C 5 4 1 by 2 into 1 by 2 of this program. Again we need to see whether okay, let's discuss next question of the binomial distribution. First of all, by observing the question, by reading the question, we need to determine whether it is related to binomial distribution or not. Yes, of course it is also related to binomial distribution. How? Okay, check it. A certain city has 60% male population and 60% population is of male. It means 40% will be of female, and from those population, if 5 of them are selected, now from this information we can easily determine the trial is Bernoulli trials, because number of trials are finite and in each trial the probability of successful outcome is same. Because here question number 1 of this, we need none of them male, means we need female. So for first selection female will be same, again for second also female will be same, and third also probability of getting female will be same. So just by 2-3 points we can be sure whether the related question is related to the Bernoulli trials or not. Hence here we can apply the concept of binomial distribution. So how do we solve? Here 5 number of trials is 5, male population, so probability of success, here we need number 1, we need female, so probability of getting female will be 40%, that is 40 by 100, 4 by 10 is 2 by 5. So probability of failure outcome 1 minus P will be 1 minus 2 by 5 equal to 3 by 5. Then R, none of them male, probability of getting female 5 times, none of them male, 5 times female we need. So combination of 5 P to the power R into Q to the power N minus R, which gives us the value of this probability. Second question, exactly 3 are male. Now here P will be probability, we need male here, so P will be probability of getting male, and we have male 60%, that already we have calculated 3 by 5. So for this Q will be 1 minus 3 by 5 equal to 2 by 5. Now 3 are male, R equal to 3 is C 5 3 P to the power, P means 3 by 5 to the power R into Q to the power N minus R, and the simplification will gives the value of this probability. Have a look. Okay, now another question, another problem related to binomial distribution. We come across this also, mean standard deviation binomial distribution. If we are asked to calculate the mean of binomial distribution, we can use this formula, n into p where you know N is number of trials and P is probability of successful outcome in each trial. Similarly, standard deviation N into P into Q under root N is number of trials, P is probability of successful outcome in each trial, and Q is number of failure outcome in each trial. And binomial distribution P plus Q to the power N, the value is always 1 because P plus Q is 1 and 1 to the power N is 1. So if we are asked to calculate this, we can apply this formula direct. Let's look at question number 4. Next question. So here, in 8 throws of a dice, turning 1 or 6 is considered to be success. Already mentioned in the question that if 1 or 6 come, we can say this is the success. It means we need 1 or 6. So here we can write number of trials. Number of trials is 8, turning 1 or 6. Probability of success P, 1 or 6. So 1 or 6 out of total sample space of a dice, there is only 1 and only 1 6. So this will be 2 out of 6, 1 by 3. And probability of failure Q 1 minus P, that is 1 minus 1 by 3 is 2 by 3. Now find mean. Mean is N into P, put the values N into 1 by 3. Again standard deviation, root under N P Q, root under 8 into 1 by 3 into 2 by 3. The simplification will give the value of this. So hope you have understood the concept and the method to solve the problems of binomial distribution. On basis of this, you will be able to solve most of the problems of binomial distribution. In next video, I will be coming with the new topic. Till then, have